common misconception exists regarding the maximum number of breakers permitted in a 100 amp electrical panel. It is not true that a 100 amp panel is limited to only 12 breakers. The actual capacity of a 100 amp panel is significantly higher, accommodating up to 40 single pole breakers or 20 double pole breakers. To understand this, it's essential to differentiate between the physical space available for breakers and the panel's overall amperage rating. The 100 amp rating refers to the maximum amount of current that the panel can safely handle at any given time. The number of breakers that can be installed is determined by the number of available slots or spaces within the panel enclosure. Most standard 100 amp panels are designed with a specific number of breaker slots, typically ranging from 20 to 40. Each slot can accommodate either a single pole breaker, which controls one 120-volt circuit, or a double pole breaker, which controls a 240-volt circuit. A single pole breaker occupies one slot in the panel and provides power to a single circuit. Double pole breakers, on the other hand, occupy two slots and are used for circuits that require a 240 volts, such as electric ranges, water heaters, and air conditioners. It is important to note that the total amperage of all the breakers in the panel should not exceed the panel's overall rating of 100 amps. This is where the concept of load calculation comes into play. A load calculation is a process of determining the total electrical demand of all the circuits connected to the panel. This calculation takes into account the wattage of all the appliances, lights, and other electrical devices that will be used simultaneously. The National Electrical Code, or NEC, provides guidelines for performing load calculations to ensure that the panel is not overloaded. Overloading a panel can lead to overheating, trip breakers, and even electrical fires. The NEC specifies various factors and formulas to be used in load calculations depending on the type of occupancy, the size of the dwelling, and the types of electrical loads involved. These calculations help to determine the appropriate size of the service entrance, the panel, and the individual circuit breakers. When performing a load calculation, it's crucial to consider both the continuous and non-continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. The NEC requires that continuous loads be calculated at 125% of their rated amperage. This is to account for the additional heat generated by continuous operation. Non-continuous loads, on the other hand, are loads that operate for less than 3 hours at a time. These loads can be calculated at 100% of their rated amperage. After calculating the total load, the next step is to ensure that the panel's amperage rating is sufficient to handle the load. If the calculated load exceeds the panel's rating, the panel must be upgraded to a larger size. It is also important to ensure that the individual circuit breakers are properly sized to protect the circuits they serve. Circuit breakers are designed to trip and interrupt the flow of current when the current exceeds the breaker's rating. This protects the wiring from overheating and potentially causing a fire. The NEC specifies the appropriate size of circuit breakers for various types of circuits, based on the size of the wiring and the type of load being served. For example, a 15 amp circuit breaker is typically used for lighting and general purpose outlets, while a 20 amp circuit breaker is used for kitchen outlets and other heavier loads. When installing or replacing circuit breakers, it's essential to use breakers that are compatible with the panel. Different manufacturers use different designs, and using incompatible breakers can create a safety hazard. It's also important to ensure that the breakers are properly installed and securely connected to the panel's bus bars. Loose connections can cause overheating and arcing, which can also lead to electrical fires. In addition to the number of breakers and the load calculation, there are other factors to consider when determining the suitability of a 100 amp panel. These include the age of the panel, the condition of the wiring, and the presence of any existing electrical problems. If the panel is old or shows signs of damage, such as rust or corrosion, it may be necessary to replace it even if it is still capable of handling the load. Similarly, if the wiring is old or damaged, it may need to be replaced to ensure electrical safety. It's always recommended to consult with a qualified electrician to assess the condition of the electrical system and determine the appropriate course of action. A qualified electrician can perform a thorough inspection of the panel, the wiring, and the overall electrical system to identify any potential hazards and ensure that the system meets all applicable codes and standards. In summary, a 100 amp panel can typically accommodate up to 40 single pole breakers or 20 double pole breakers, depending on the design of the panel. However, it's crucial to perform a load calculation to ensure that the total amperage of all the breakers does not exceed the panel's rating. It's also important to consider the age and condition of the panel and the wiring, and to consult with a qualified electrician to ensure electrical safety. Understanding these factors can help to avoid electrical hazards and ensure that the electrical system is operating safely and efficiently. Furthermore, it's important to remember that electrical codes and regulations can vary depending on the location. It's always a good idea to check with the local building department or a qualified electrician to ensure that all electrical work is performed in accordance with the applicable codes and standards. This will help to ensure the safety of the occupants and prevent any potential electrical problems.